Okay, welcome to the last video in our Unit 13 right triangle family. So we've been talking about right triangles, and today what we're going to do is talk about distance. In this video we will talk about how to find and calculate distances. And actually we've already done that, haven't we? In the last video, which was on right triangles in real life, we calculated a distance. It was the distance between these 2 points on a map. And since there was a right triangle in that situation, you could use the Pythagorean Theorem. Well, we're going to do the same thing today, except instead of on. So can we find the distance between 2 points on a graph? Yes, we can. And instead of an x, I'm going to call that distance a d for distance. And we can calculate the distance between those 2 points even if they're diagonal from each other, and even if it's kind of a crooked line. So all we have to do to find the distance between those 2 points is use the right triangle between those 2 points. Notice that from -4, -5 to 5, 5, you have to go to the right 9, and then you also have to go up 10. So if you want to pause the video, you can count the number of little boxes on the grid to make sure I did that right. But basically that's all I did, is I counted the little boxes on the grid. And when I did that, since I went to the right and then straight up, it made a right angle, which made a right triangle, which means that to find the distance between any 2 points on a graph, all I have to do is just sketch out a graph of the right triangle distances and then find the hypotenuse of that right triangle to find the straight distance between those 2 points. Basically what I'm saying is we're going to use the Pythagorean theorem here. So, and I'd say 9 squared plus 10 squared equals d squared. Hopefully you can see where I got all that. Then we just have to finish it off. What's 9 squared? 81. What's 10 squared? 100. And you add those together, you get 181, and you've got to unsquare that to get d. So we're going to do the square root of 181. So the distance between those 2 red dots is about 13.5. Not exactly 13.5. We had to round that irrational square root up or down a little bit, but it's roughly 13.5. And you're going to have to round some of your answers when you do these problems as well. All right, so let's try another example just to make sure you got it. If you were trying to find the distance between 2, 4 and -1, 0, here's what you would have to do. You would plot those 2 points. And then you would make a triangle. And that's where you're going to have to start to do some math. So first you're going to figure out how far is this leg right here. Well, you just count the boxes. 1, 2, 3. So this is 3. And then how far is this here? 1, 2, 3, 4, right? So this is 4. Oh, guess what? I already kind of know that this is just a 3, 4, 5 right triangle, but just to make sure that you get it, I would do 3 squared plus 4 squared equals d squared, d for distance, right? Or you could put h for hypotenuse or whatever you want, and then I would just square the 3, square the 4, add them together, and we know what squared makes 25, but just to show you what we're doing here, we're going to unsquare the 25 and get the distance this time is, those are exactly 5 away from each other. All right, so that's how you can find the distance between any 2 points on a graph. What I want you to do is try it on your own. So plot those 2 dots. Make a straight line between them, but then make a right triangle to connect the 2 dots and use a squared, b squared, c squared. All right, now we did this problem just a second ago, right? What I want to show you is that we can do it a different way. Instead of using a graph to do that, we're going to use something called the distance formula. If you don't like drawing graphs out every time that you have to do this, the distance formula is good news because it's a way to do it with just the numbers. Except, oh boy, Look at that formula. It's kind of scary, huh? Well, I'm going to show you that this formula is not as scary as it looks. The x1, x2, y1, y2 are really just symbols to represent the 2, the 4, the -1, and the 0 that you see over on the upper left corner of the screen. So the distance formula isn't that bad. All right, the x1 is the first x-coordinate. It's the x-coordinate of the first point. The x2 is the second x-coordinate. It's the x-coordinate of the second point. So x1 is 2, x2 is -1, y1 is the first y-coordinate, and y2 is the second y-coordinate. Okay, that's not too bad. So now what we're going to do is we're going to go ahead and plug those numbers in where they belong. We said that the 2 goes here, the -1 goes here, and then the first y-coordinate goes here, and the second y-coordinate goes here. So all I really have to do now is put those numbers in there. So this one was 2. So I'm going to put 2 minus, wait, what was x2? Oh, x2 was this one. 2 minus -1. What happens when you do minus -1? Oh yeah, that becomes plus +1. This is really just 3 squared. Plus this whole stuff here. Well, what am I going to put in for y1? y1 was the first y-coordinate minus y2, which is the second y-coordinate. Oh, I know what 4 minus 0 is. 4 minus 0 is 4. But remember, we're squaring both of these, so I'm going to put 4 squared here. And it's the square root of this whole thing. See that? It's the square root of the whole thing. So now what I have to do is go back and do 3 squared, which is 9. Do 4 squared, which is 16. Add them together, which is 25. And if this is starting to look a lot like what we did the first time around with the Pythagorean theorem, it's supposed to, because these were the same 2 points, so the answer should come out the same, and it does. So the distance is 5, and you can use the distance formula to find that distance if you don't like drawing pictures on a graph every time. Personally, I think the distance formula gets a little complicated, but I'll show you an easier way to do this. This part right here, whoops, go backwards please. Technology problems. This part right here of the distance formula is x1 minus x2. Well, couldn't I just kind of go like this and do x1 minus x2, 2 minus -1? And then couldn't I do this part as well? y1 minus y2. I'm just going to subtract here and do 4 minus 0, which is 4. And then can't I just square this one, add them up, and take the square root of that? Oh, maybe that's an easier format to do this. And that way, you don't necessarily have to remember all of the x1, y1, x2, y2. You can just line the 2 points up like this, and then just subtract, square, and square root. I don't know if that makes sense at all. I'm just trying to help. Maybe it doesn't make sense, but you can finish this problem the same way we finished the problem before, and you get the same answer either way. And maybe after we've done all this scribbling and writing, you're deciding that sketching out a little graph and making a little right triangle might be your best option. But I'd like you to at least try this practice problem, and I'd like you to at least try the distance formula on this. I'll give you a little hint. The first step that I would do if I was doing this would be to put 3, 2 down here, and then I would maybe do a little subtraction. You can see if you can get it from there. All right, that's distance. And I hope you now see how finding distances is related to right triangles.